So good morning to all of you. Now in this lecture we are interested to discuss about the comparison between Gauss elimination and Gauss Jordan. So as an introduction, Gauss elimination method is a method to solve linear system by converting a matrix into an upper triangular form. This is very important key point. Okay, and then we use back substitution. Then the key difference between Gauss elimination and Gauss Jordan elimination. Gauss Jordan elimination extends Gauss elimination by reducing the matrix into reduced row echelon form called RREF. Okay, yielding a direct solution, right? And uh, both methods use row operations. Three elementary row operation. Swapping rows, any rows we can swap Ri and Rj, and multiplying a row by a scalar, non-zero scalar where k is non-zero, and adding or subtracting any rows Ri changes to Ri plus minus k times of Rj. Right, so this is three elementary row operation which we have already discussed in first video. Now workflow comparison. So workflow comparison. So Gauss elimination method and Gauss Jordan elimination method. So forward elimination. So convert to upper triangular form, right? The Gauss elimination converts the matrix into an upper triangular form, and Gauss Jordan will do the same, right? We will also convert into an upper triangular form. Back substitution. What about the back substitution in Gauss elimination? Yes, it is required to find the solution. But in Gauss Jordan, it is not required, right? So it is not required. And additional steps. Additional step is not there in Gauss elimination because we have to convert into a triangular form and then we do back substitution. Okay. But in Gauss Jordan elimination, yes, further elimination is required to reduce to RREF, reduced row echelon form. Okay, this is the two key difference between Gauss elimination and Gauss Jordan elimination. Okay, so let us see one challenging problem. So solve the system of equations 2x plus 3y minus z equal to 5, 4x plus y plus 2z equal to 6, and 6x minus y plus z equal to 10. So initial augmented matrix is A augmented B. We write A augmented B as A augmented B, the coefficient matrix and their entries, and B and the column, right? And then we do apply the elementary row operation, right? So forward elimination. So forward elimination in Gauss elimination, we will not make this pivot entry as one, right? But in Gauss Jordan, we have to make it one. This is very important point, a difference. So now these are the two elementary operation if I do, because two times if I do in first row, so it become 4, and three times if I do and subtract it from third row, then it becomes 0. This pivot element is first row, first column element, and then if it is 0, let's say if this is 0 for instance, then we will look in the same column any non-zero entries. If any non-zero entries are there, then we will switch it to the first place, and then we start the process of making zeros in the remaining one. Okay, so this is fortunately non-zero, so we can take as a pivot element and then make 0 to the below column. Okay, so these are the two elementary operations we are using to make 0 0. Okay, and then again we do take this as a pivot element, because once this pivot element is obtained, we need to switch the next column and lower row. Lower row is the second row, R2, right? So we find non-zero entry and then we have to make it 0 to the below column elements. Okay, so now we apply this elementary row operation to make 0 to this element. Okay, and then we do back substitution. So here we are going to do back substitution. So this is basically your you can mark it like this, mark it like augmented matrix type of things you can make, and then now you can solve for z from back substitutions, right? So minus 4z equal to 3. After multiplying minus 4, z equal to 3 by 4 with negative sign, right? So now mm, this is going to be your back substitution. Then once z value is confirmed, then go to back and then substitute accordingly. So we found the solutions in this way, right? Here the minus sign will be written here, right? Because minus is not at all into the picture. Okay, so this minus you can write it here outside also. Okay, and similarly you will get the solution, right? And this minus you can write in the above. Okay, because division by because length is non-negative, so division by minus is not looks good actually, and not correct also. So we are always writing negative. Otherwise you can see minus 4z equal to 3. So you can obtain this step c equal to 4z equal to minus 3, and then z equal to minus 3 by 4. You pre-multiply both side by minus 1 to get this entry, right, rather than dividing by minus 4. Okay, so anyway, so now we found the solution using Gauss elimination. Now we'll do with Gauss Jordan as well. So Gauss Jordan, what we do perform first, we normalize the R1. Like first we make the identity element to 2 as 1. Okay, so we have to divide R1 by 2, so which will become 1. This is mandatory in Gauss Jordan elimination. Okay, and then we do perform subtracting 4 times and 6 times from R2 and R3 to get 0 0 here. And then again, once this is done, then we switch for the another row. So first reduce triangular form, and then we do from the rightmost pivots entry from the column. So this entry then makes 0 to the above, then makes 0 to the above pivot, and find the final solution. So final solution which we have obtained is same as the Gauss-Jordan method. Okay, so Gauss-Jordan and Gauss elimination both are same. Now key advantages where we are using most likely these two methods. So as we talk about the efficiency, so Gauss elimination is faster for large systems, right? But Gauss Jordan is slower due to additional steps, right? And direct solution, so requires back substitution, but direct solution here in that case, direct solution via RREF. So here in Gauss Jordan, you will read solution directly, as you can see from here, x equal to 7 by 4, y equal to 1 by 5, z equal to minus 3 by 4. So this is direct way of reading solution, Gauss Jordan elimination. But this requires back substitution, Gauss elimination. And application where it is mostly used, so application in solving equations, right? As well as in numerical analysis, right? This is used in numerical analysis. And this is Gauss Jordan is used for solving equations as well as finding inverse of a matrix, right? Matrix inversion, right? And overall the conclusion, so Gauss elimination efficient for solving equation using back substitution, and Gauss Jordan provides direct solution useful for matrix manipulation, and both rely on intermediate steps like row operation and triangularization. Okay, so this is all.